Okay, we mentioned the several different contexts that subtraction can show up under. So we're going to focus, all these problems are going to focus on subtraction as kind of a compare problem. And we're just going to focus on the context of difference. So we're kind of comparing two things. We're finding the difference between two things. I'm going to go over this first problem again. So the first problem, I was tackled for a 4-yard loss on my first rushing attempt. My best friend was able to gain 6 yards on his first attempt. What's the difference between my attempt and his? Okay, now this has nothing to do with the football field. So the relation to the football field is irrelevant, because maybe my first attempt, I lost 4 yards, and then 20 plays later I was pulled and my friend was put in. So I'm just comparing my first attempt to my friend's, but the position on the football field is totally irrelevant. So my first attempt was a 4-yard loss, so I'm going to represent that with a -4. And then my friend's, his was a 6-yard gain, so I'm going to represent that with a +6. So now let's start playing around with the difference between me and him and me. So first, the difference between my attempt and his. So the difference is the key word. And this is indicating the operation of subtraction. So now let's set up an expression. Me first, which is a -4, operation, subtract, and then him, he was a +6. So there's what we've got, -4 subtract +6. Okay, that is going to be a -10 if we simplify it, and if we try and show it on the number line, we've got 0, I'm somewhere -4, he's over here at 6. Okay, the difference between me and him, I'm going to start it on him and work from him to me. So between these two, the distance is 10, but the direction is negative. And then if we reverse that, what if we look at the difference between his attempt and mine? So keyword is difference, means subtract his first, which is +6, subtract mine, which is a -4. And the difference is now we're starting on me, and I'm working to him. So the distance is the same, but the direction is totally different. So this one is going to be a +10. Okay, the next problem. My parents gave me and my brother $20 each to spend at Lagoon. I've already blown through my amount and even borrowed $5 from my parents. My brother still has $7 to spend. What's the difference between my financial status and his? Okay, my status, I'm going to represent that blown through my money I borrowed, so I'm -5. My brother, he has yet to spend, so he still is $7 ahead. He still has $7 to spend, so I'm going to say it's +7. Okay, the difference between, so difference, that means that's indicating subtract. Mine and his, so mine is a -5, subtract his is a +7, and if we simplify that, we should get -12. Okay, now let's look at it on the number line. So my status, here's 0, I'm at -5, he's at 7. So the difference between my status and his, so I'm going to start at his, and I'm going to work my way to mine, and from there to there is a -12. But if we reverse it, what's the difference between his status and mine? So I'm going to put his status first, which is 7. Difference is subtract. My status was in the whole $5. So now I'm going to start on mine and work my way towards him. And now that is a +12. Okay, now the bottom one, after borrowing and spending the $5 my parents gave me, I was able to talk them into lending me another $7 for the kissing booth. What is my financial status now? Okay, this problem's a little bit different. Because it's not a compare problem. It's kind of a join problem. So my financial status was a -5. and then I talked them into lending me some more, so I'm going to add to that another $7. So my debt plus another debt of $7, my total is negative 12 now. So this one was kind of a join problem. Okay, let's look at different context. My grandma and I both live on Center Street. I live 4 blocks west of Main, and my grandma lives 6 blocks west of Main. So I'm going to set it up kind of like a number line. I'm going to say this is Center Street right here. And Main is going to go this way. So here's Main. Okay, I am 4 blocks west of Main, so somewhere in that neighborhood. 4 blocks, this is me. And then my grandma's 6 blocks, so I'm pretty close. There's my grandma. So we're both west of Main, so I got 2 options. I can use east and west to indicate orientation, or somehow I gotta get oriented. You can use east and west, or you can use positives and negatives. This is the positive side, this is the negative side. So in this case I would be at -4 and my grandma would be at -6. But I think we can make it work with just west and east. So what's the difference between her house and mine? Okay, her house, she is located at 6. Difference indicates subtraction. My house is at 4, so 6 subtract 4. And that's going to give me 2. But over here, if we use the negative and positive orientation, her house is -6. Operation is subtraction. My house is -4. And this is a -2. So there's a big deal. And the negative is telling me direction. So check this out. You can't just leave this as 2. You've got to tell me the direction, and we are going to the west. So it's either got to be -2 or it's got to be 2 to the west. So 6 subtract 4. If you think of it as the difference between 6 and 4, you got to start at 4 and work your way towards the 6, and that is 2, but it's in a westward direction. So 2 to the west. Or here, the difference between a -6 and a -4, I got to start at -4 and work my way to -6, and that is 2 in the negative direction. So these are kind of big deals, this idea of direction, either west or negative. Okay, now if we reverse it, what's the difference between my house and hers? So again, difference is indicating subtraction. My house, I was at 4, subtract her house, she was at 6. So now if I start 4 subtract 6, that means I'm going to start at 6 and work my way to the east. So 4 subtract 6, I'm going to go 2 blocks, but I'm going in the east direction. So now what's the difference between my house? My house is a -4, and her house, the difference, that subtract her house, she was at -6. So now start at -6, go to 4, that's 2 positive. So the orientation totally matters. The direction totally matters. But now this last question gets interesting. What's the distance between our houses? And distance, I'm going to argue distance is a little bit different than difference. So the distance does not care about direction. The distance is how far we're going to travel either way, from mine to hers or from hers to mine. So the distance, this is the key word right here, and when we come across distance, that's got to have a ringer go off in our head that that's talking about absolute value. So type 1, if I'm using this east and west, so the difference between my house and my grandma's is pretty dang close to the distance between my house and my grandma's. So I want the distance between. The operation for distance is still subtraction. The thing is, I don't care about the direction. So I'm either going to take 6 subtract 4, or I'm going to take my house subtract my grandma's house, 4 subtract 6. And they're both going to give me a distance of 2. But if we use this negative positive orientation, I'm going to do my grandma's now is this one is 6 to the west, but this one is negative 6. And the distance, to find the distance between things, the operation is subtraction. Subtract my house, negative 4, or it is going to be my house, negative 4, subtract my grandma's house, which is negative 6. And all 4 of these give 2 for the answer. The distance is going to be 2. Direction doesn't matter. Distance is 2. Okay, let's look at one more. This time, my grandma and I both live on Center Street. I live 4 blocks west of Main, and my grandma lives 6 blocks east of Main. So, here's Center Street. Here's Main. This time we're on opposite sides. I live 4 blocks west, so let's call this my house. 4 blocks. This is on the west side. My grandma lives 6 blocks east, so she's somewhere over here. This is the east side. There we go. So this is center. This is Main. Or if you don't like the east-west orientation, let's use positive, negative. I think we can make them both work. This is Main. This is center. Alright, I am, my grandma's 6 blocks positive. I am 4 blocks negative. Alright. Okay, now, what is the difference? So difference is, that's the key word. That's indicating subtraction. Between her house and mine. So her house is now 6. But see, now this is where it gets kind of tricky. Because I've got to indicate now that 6, this is 6 to the east. Let's see, her house and my house, difference is subtract. My house is clear over here, 4 to the west. So this is why the positive and negative becomes kind of a better route to do, because check this out, if I do the difference between her house and my house, her house is 6. Difference is subtract, but my house is negative 4. So the negative is the same thing as west, and the positive is the same thing as east. But the problem before, we were both on the west side. So we both had like a west here and a west here. We had the same direction. But now we live on different sides of the street. So I'm going to start from my house and work my way to my grandma's house. So if I start at my house and work my way to my grandma's, I'm going in an east direction, and I travel 10. The difference is 10, but it's 10 to the east. Now on this one, 6 subtract a negative 4. The difference between 6 and a negative 4. Start at negative 4, go to 6. The difference is 10, and it's positive. So let's look at this next one. What about if we switch it? What's the difference between my house and hers? So my house, I am at 4, but I'm to the east. The difference is subtract, and she is 6, but she's on the west side. Okay, let's look at the positive and negative. I like this a lot better over here now. The difference between my house was a negative 4. Difference is subtract her house, she's at a positive 6. Okay, now this means we're going to start at her house and go to my house. And she's going 10, but she's going in negative direction. Same thing, start at her house, go to my house. She's going 10, but she's going 10 to the west. Okay, now this word, what if we throw in the word distance? Okay, now distance is opens up a new can of worms, because distance is pretty dang similar to difference. They're both, the operation is subtraction on both, but we're not concerned about which direction we're going. I just want the distance, so either or will be fine. So now I'm going to use this one right here. I'm going to use the positive negative orientation. So the distance between mine and my grandma's, here's mine, a negative 4. To find the distance between them, I got to use the operation subtract. My grandma's right here, 6. So I'm going to put absolute values, and that indicates the distance. We don't care about the direction, I just want the distance is 10. Or I can go from my grandma's to my house. I can go from grandma's. The operation is subtract to find the difference between these two, and my house is at negative 4. And that really is the same as 6 plus 4. So the distance between 6 and a negative 4, and we mentioned that in class one time, the 6 plus 4 really is the exact same thing as 6 subtracted negative 4. And that is going to be distance of 10 also. Okay, now then we jump into vectors. And vectors, this again, the purpose of this is just for you to have maybe broaden your understanding on the idea of vectors and how they play together, because they're very useful in modeling problems on a number line. And I'm not sure about introducing this to kids, but if you as a teacher understand, have kind of a big picture concept of vectors and how they play together, hopefully it will allow you to be more powerful in your instruction to the kids. So I told you I wouldn't put something like this on the test, but for fun, let me review, not all of it, but just quickly, let's do an addition problem. So if you have vector A, his tail is at 2, 2, so I'm going to go over 2, up 2, that's his tail. His head is over 4, up 6. So that means we've got a vector that looks like that. Maybe. Okay, let's try this. We've got a vector that looks like 2, 2, and then over 4, up 6. We've got a vector that looks like this. Okay, vector B. Let's change colors maybe. Vector B, his tail is at 9, 1. So over 9, up 1. And his head is at over... Oh, his head's at the same place. I wonder if that was a accident. Okay, so their head is at the same place. Now, what happens if we add A to B? So I got two vectors. They're going in different direction, they're different length. When you add vectors, you take one of them. So if I'm going to add A plus B, so I'm going to add B to A. So B was my second one, this is my red one. I wonder if I can grab it. There we go. But I don't know if I can move it. I don't think I can move it. Oh, that's lame. So pretend I could move it. I'm going to pick it up. You have to put the tail of it on the head of vector A. So I'm going to put the tail right here, and then I've got to keep it going the exact same direction, and I've got to keep it going the exact same length. You can't change the direction or the length. All I do is just pick it up and put its tail on vector A's head. So I gotta go the same direction, and I cannot change the length. So I'm gonna go over one, and here's how I figure out the length of it. If I go from the tail, I'm just gonna go horizontally over and then vertically up. So if I go over 1, 2, 3, 4, 5, and up 1, 2, 3, 4, 5, so over 5 and up 5. So over 5, 1, 2, 3, 4, 5, and up 5, 1, 2, 3, 4, 5. So here we go. I've got to move it to something like right there. Now, vector A plus B, so I got vector A right here, and then I got vector B right here. I add them together, I put them head to tail. The vector A plus B is this vector right here, the blue one. And it is going from the tail of A where I started, and it's going to end up where B ended up. So this right here is vector A plus B, this blue one. And then subtract. When you subtract vectors, you do the exact same thing, but then you change the direction of B. So I would 180 the direction. I would go in the total opposite direction. So here's what we did. I've got a vector of 4. So there's my vector of 4. And this really is 4 subtract, it's 4 subtract positive 6. The operation is subtract. So a vector of positive 6 is a vector like that. It's going in positive direction. It has magnitude 6, or it has length of 6. Okay, now to subtract vectors, I have got to take this vector of 6, I've got to 180 it, I've got to change the direction, I've got to reverse the direction, and then I place it head to tail. So this is the tail. I'm going to put this tail on the head of my first vector, change the direction. So there we go. Then your additive inverse says any zero pair, all these zero pairs are going to negate each other, they cancel out, and you are left with a vector right here. This vector has magnitude of 2, but it's going in negative direction. So we're going to limit our vectors to horizontal directions. Whereas if we introduce kind of 2 space or 2 dimensions, your vectors can go they can go diagonally, vertically, horizontally, any direction you want. But if I'm limiting to one dimension, then our vectors have got to be horizontal, and that's it. So this one, I've got a vector of 4, and it's positive. I've got a vector magnitude 6, but it's negative. Okay, now I'm going to add these vectors together, and add, you don't change the direction of anything. All you do is pick this vector up right here, the second one. I'm adding the second to the first, so I pick this second one up, put its tail on the head of this one, and then let it run out. And it was, how far was it? Negative 6. So additive inverse says all these opposite directions are going to zero out, and I'm left with this chunk right here, which is a magnitude of 2 but negative direction. So the same solution, but 2 totally different contexts, even in vectors and chips. Okay, negative 4 subtract 6. The vector negative direction, magnitude 4. And then this vector is actually a positive 6. So we're going in the positive direction. And I'm going to, let's see, negative 4, I'm going to subtract. So subtract means I need to change the direction of this second vector. So I got to turn him around. And then I got to place it head to tail. Here's his tail. I got to pick his tail up and drop it right here. And now I've got a vector coming magnitude of 6. So my final vector, these two are going to add together. So I'm going to have a vector of magnitude 10 negative direction. Okay, negative 4. If I've got a vector in negative direction magnitude 4 and a vector of magnitude 6 negative direction, so they're both going the same direction, but now I'm going to add these two vectors. I'm going to add the second to the first. So leave the first where it is. Pick this second up. Put its tail at the head of the first. And then run it out. And we will have a vector similar to the first. We're going to have vector magnitude 10, length 10, direction negative. So two same solutions but different contexts. And then the final one, I've got a vector of negative 4. So negative direction, length of 4. I've got another vector, negative direction, length is 6. Okay, now I'm going to subtract the second from the first. So subtract means I need to change the direction of the second vector. So I got to 180 it, flip it around, and then place it head to tail. So this tail right here, put it on the head of this vector and run it out. And now your additive inverse, these different directions are going to negate each other. They're creating zeros, and you're left with a vector that is magnitude 2 and its positive direction. Then the last one, I've got a vector of 4. I've got a vector of 6 but in a negative direction, and I need to subtract these vectors. So subtract says you've got to take, I'm going to subtract the second from the first. So I'm going to 180 this vector right here, change the direction, and then place it head to tail. So I'm going to put its tail on this guy's head and then run it out, and your total vector runs from here to here in a positive direction, and it has length 10, magnitude 10. And that is it. So, good luck.